This is the solution to problem 42 in the Math Level 2 practice exam. If a positive integer n is divisible by p, and by divisible it means that there are no remainders, where p is an integer, then it must be true that. So let's see if we can come up with some sort of example. Like, let's say if n is 36 and it's divisible by 9. That's true. That's an example that could fit this scenario. And so if n was 36 and p was 9, let's see if we can maybe eliminate some choices, because the problem statement is then it must be true that. So for our example, this is an example, so it should be true in our whatever answer is correct. It should work with our example as well. All factors of n divisible by p. So let's see. All factors of n. What are some factors of n? Let's say 3. 3 is a factor of n. Is that divisible by 9? No, 3 is not divisible by 9, so that's out. P is prime. Well, our P is certainly not prime. 9 is not a prime number, so that is not always true. There are infinite prime factors of n. Well, for any integer, you're going to have a finite number of factors. So for our example, that's a general statement, but even for our example, 36 equals 2 times 2, which is 4, times 3 times 3. So it's 4 times 9 is 36. Now, I think what they're trying to get you to say is that, well, 1 is a prime number, and you keep multiplying by 1, and it's infinite, infinite prime factors. Of n. But the thing is, 1 is not a prime number. The first prime number is 2. So C is out. At least one of the prime factors of n is divisible by p. Well, p is 9. Are one of these prime factors divisible by 9? No, not necessarily the case. Well, in this case, it certainly is not. So D is out. Prime factor. There are factors of 36 divisible by 9, but not any prime factors. Prime factor of n divisible by p, no. At least one factor of n, and that's what we're getting at. 3 times 3 is 9. That is a factor of 36, and of course 9 is divisible by 9. And you could say 9 times 2, 18. 18 is a factor of 36, and it is divisible by 9. So E is your answer.